So we're going to go ahead and we're going to practice some pH problems. Here we have a first problem. It says, what is the pH of a 0.023 molar solution of HCl? And then we also have a question about what is the pOH based off of that. So I see that I have a leading hydrogen, which would make this a acid, and therefore I can go ahead and just directly calculate H. This molarity is going to be my concentration. So go ahead and say that my concentration of hydrogen ions will be 0.0235 molar, which means that I can go ahead and plug it into the equation. pH is equal to the negative log of the concentration of hydrogen. And I'll go ahead and plug that into the calculator. So negative log. That gives me a pH of 1.628932138. Let's go ahead and round it to 3 decimals. 9 makes me round up, so my pH will be 1.629. And of course I'm not done. It also asked me for my pOH. We know that pH plus pOH is equal to 14, so if I'm solving for pOH, I would need to subtract pH from both sides. So that would give me pOH is equal to 14 minus pH, which would mean I would need 14 minus this 1.629. And so that would make my pOH 12.371. Okay, my next question says, what is the pH of a 6.5 times 10 to the negative third molar potassium hydroxide solution? I don't have a leading hydrogen, and instead I have hydroxide mentioned. That means that this is going to be a base, which means that I cannot directly calculate pH first. I need to calculate pOH. And so pOH is equal to the negative log of the concentration of the hydroxide ions. The concentration is just going to be the stated molarity. So negative log and that will give me pOH. Now, I wrote down times 10 to the negative fifth. I'm going to be using an EE button instead. So negative log 6.5. And then again, instead of times the 10 and the caret, I'm going to go E, negative 3. And that gives me a pOH of 2.187. And now I just need to calculate pH. pH plus pOH is equal to 14. If I want pH, I need to subtract pOH from both sides. So pH will be equal to 14 minus the pOH, which means that I will have 14 minus 2.187. Okay, and it is a pH scale, and so this 11.813 does reveal that this is a basic solution, just as I predicted with having a hydroxide ion. So my next problem here says, what is the pH of a 6.2 times 10 to the negative fifth molar sodium hydroxide solution? So again, same type as here. I see hydroxide instead of a leading hydrogen, which means I need to calculate pOH first. So pOH is equal to the negative log of the concentration of the hydroxide, which means I'm just going to be able to use this molarity here. Instead of writing times 10 to the negative 5, I wrote E this time because that's what we will see in our calculator. So negative log 6.2 E negative 5. gives me a pOH of 4.208. And I want pH, and pH is equal to 14 minus the pOH. That's what we derived here, so I'm going to go ahead and use that since I already did the work for it. So 14 minus 4.208 will give me my pH. And that will reveal if I am correct about this being basic. The number that I get is 9.792. That is on the basic end of the scale, so it does look like sodium hydroxide was correctly identified as a basic solution. Okay, so it says if the concentration of hydrogen ions is 2 times 10 to the negative 12th molar in a perchloric acid solution, what is the pH? Okay, this one's nice. I have a leading hydrogen, which means that this is already an acid. So I can just go ahead and use this molarity, and I don't have to do any extra calculations. So pH is equal to the negative log of the concentration of hydrogen. That is my concentration of hydrogen, so negative log. And remember, this times 10 to the negative 12th is going to appear as an EE in my calculator. So negative log 2.1 EE negative 12. And that gives me a pH of 11.678. Okay. That means that this is so weak that I actually end up being a basic solution. Last problem here, we say what is the pOH if the hydroxide concentration is 5.9 times 10 to the negative 1 molar. This again is going to be an easier one. I'm just asking for pOH, and I am immediately given something that is already in the concentration of hydroxide, so I can just go ahead and plug this in. So negative log 5.9 E negative 1 gives me a pOH of 0.229. And that was what we were asked for, so we are golden, we are done.